Hello, this is Mrs. Decker, and in this video, I'm going to go over 4.1e on converting between mass and the number of particles of a substance. So these are two-step calculations. You'll either be given the mass of a substance and need to find the number of molecules, or the number of molecules and need to find the mass. Both of those conversions will need to go through moles first. That's why we say they're two-step conversions.
So looking at Mole Island, we see that moles is in the center. So if we are given the mass of something, we can calculate the number of molecules as long as we convert to moles first. If we're giving molecules, we can find the mass as long as we convert to moles first. So the key is to always convert to moles and then convert to the other value you're looking for. So our first example problem says how many molecules are in 2 grams of FeF3. Our given information is FeF3, grams of FeF3, and we're looking for molecules of FeF3. So if we look at Mole Island, we're starting here at mass, and we want to get to molecules. So the first step is to convert to moles, and then from moles, the second step is to convert to molecules. So start with your given information, 2 grams of FeF3, and we want to convert to moles of FeF3. To do that, we use the molar mass, and the molar mass of FeF3 is 112.81 grams in 1 mole. Okay, so now grams of FeF3 cancels out, and we're at moles. We don't want to stop at moles though, because the question is asking for molecules. So you want to extend your t-chart and now convert from moles to molecules. We do that using Avogadro's number. So you put 1 mole on the bottom and Avogadro's number on the top. So now moles cancels out and we're at molecules, which is what we're looking for. So you do 2 times 1 times 6.02 times 10 to the 23rd divided by 112.81 times 1. And when you put that in your calculator, you should get 1.07 times 10 to the 22nd molecules of FeF3. Example number 2 says how many grams are in 3 times 10 to the 23rd molecules of AgNO3. So underline your given information, 3 times 10 to the 23rd molecules of AgNO3, and put a box around what you're looking for, which is grams. So now in this problem, we're starting down here with molecules, and we want to get up to grams. So you first have to convert from molecules to moles, that's step 1, then from moles to mass, that's step 2. So your given information is 3 times 10 to the 23rd molecules of AgNO3. And draw your t-chart. So we're starting off with molecules. We first have to convert that to moles. We do that with Avogadro's number, and we're going to put that on the bottom. So 6.02 times 10 to the 23rd molecules on the bottom, and 1 mole of AgNO3 on top. So when we do the math, molecules cancels out, and we're left with moles, but we're not done because we want to get to mass. So now we have moles, and we have to go to mass. We do that using the molar mass, so we put 1 mole on the bottom, and the molar mass of AgNO3 is 169.83 grams. So now moles will cancel out, and we'll be left with grams, which is what we want. So 3 times 10 to the 23rd times 1 times 169.83 divided by 6.02 times 10 to the 23rd times 1. Now remember, there's scientific notation on the bottom here. You'll be dividing by it. So it's very important that you put the whole scientific notation in parentheses in your calculator in order for it to calculate right. So when you calculate that, you should get 84.63 grams of AgNO3. Example number 3 says how many molecules are in 5 grams of NaOH. Underline your given information, which is 5 grams of NaOH, and put a box around what you're looking for, which is molecules. So again, this time we're starting up at mass, and we want to get to molecules. So step 1 is to convert to moles. Then step 2 will be to convert to molecules. Okay. So step 1, grams to moles. We do that using the molar mass, and we're going to put the molar mass on the bottom. So it is 39.97 grams of NaOH and 1 mole on top. So grams cancels out, and we're at moles. But now we want to go to molecules, so extend your T-chart. And to go to molecules, we need to use Avogadro's number. So you put 1 mole on the bottom and Avogadro's number on top. Okay. So you'll do 5 times 1 times 6.02 times 10 to the 23rd divided by 39.97 times 1. So when you put that in your calculator, you should get 7.53 times 10 to the 22nd molecules of NaOH. Example problem number 4 says how many molecules are in 9 grams of H2O. Given information is 9 grams of H2O, and we're looking for molecules. So again, we're starting out up here at mass. We have to first convert to moles for step 1, and then molecules for step 2. So 9 grams of H2O. To go from grams to moles, we're going to use the molar mass. The molar mass of water is 17.99 grams of H2O. And that's how many grams are in 1 mole of water. So that will get us to moles of H2O, but we have to go for molecules. So you're going to put 1 mole of H2O on the bottom to 6.02 times 10 to the 23rd molecules. So now you'll do 9 times 1 times 6.02 times 10 to the 23rd divided by 17.99 times 1. When you put that in your calculator, you should get 3.01 times 10 to the 23rd molecules of H2O. Example problem number 5 says how many molecules are in 8 grams of COCl2. Given information is 8 grams of COCl2. We are looking for molecules. So we're starting up here at mass. We have to first convert to moles for step 1, then molecules for step 2. So 8 grams of COCl2. And again, we're going to use the molar mass to go from grams to moles. The molar mass is 129.83 grams in 1 mole of COCl2. So grams cancels out. We get to moles. Now we need to convert to molecules. So 1 mole of COCl2 on the bottom to 6.02 times 10 to the 23rd molecules. So 8 times 1 times 6.02 times 10 to the 23rd divided by 129.83 times 1. So when you put that in your calculator, you should get 3.71 times 10 to the 22nd molecules of COCl2. All right, and our last example problem says how many grams are in 6 times 10 to the 26th molecules of helium. Given information is 6 times 10 to the 26th molecules of He. We're looking for grams. So here we're starting off at molecules. So step 1 is to go from molecules to moles. Step 2 is to go from moles to mass. So 6 times 10 to the 26th molecules of He. Draw your T-chart. So now we're starting with molecules and we want to convert to moles. So we're going to use Avogadro's number, put that on the bottom, and 1 mole of helium on the top. So molecules cancels out. We're left with moles, but we need to go to grams. So we're going to use the molar mass, put 1 mole of helium on the bottom, 4.00 grams of helium on the top. So remember, what you're going to do is 6 times 10 to the 26th times 1 times 4 divided by 6.02 times 10 to the 23rd times 1. But again, remember, since you have scientific notation on the bottom, you want to put the whole thing in parentheses so your calculator calculates correctly. And you should get 3,986.71 grams of helium. So now there are some practice problems for you to work on in your packet. See me if you need help.